Hi, in this video we will talk about simple ways to use optical flow to track objects and the main challenges that we can find. There are several applications in which we can use optical flow, but usually we are not interested in calculate the optical flow of the whole scene, and that is evident in one of the most common applications of motion tracking, the traffic cameras. Here we have a fixed camera and we know the distance between the camera and the street. Therefore, we can use optical flow to calculate the velocity of the cars and find out when somebody is breaking the law. As we can imagine, calculating the optical flow of the full image is a waste of resources. We are not interested in the changes that might happen in the background, and there are many ways in which we can constrain the search space. For example, we could define a region of interest to perform the tracking, or search for specific features. However, a better way to start a detection system is to find a way to remove the information that is not relevant for the application. In this case, we are not interested in things that are not moving. So how do we get rid of this? The most obvious answer is to subtract both images and then apply some threshold to binarize the image. In the pixels where there is no change, we will have 0. And the pixels in which the difference was higher than the threshold, we will have 1. As you can see, we are actually removing many pixels. However, there are many that are not interesting for the application. Because we want to remove the background, another approach is to take an image of the empty background and then subtract that from each video frame. This approach might work in certain circumstances, but is not robust to changes on the illumination. We can imagine that during different times of the day, the background will change. So the best approach is to use an adaptive model of the background. For this, we can take the last n number of frames and calculate the median. The median works better than the mean. Remember that we want to take the most common values. This approach will be robust to illumination changes and will provide a good way to track moving objects. Another typical application of optical flow is video stabilization. When we record the video with our smartphone, and especially when we do it while walking, the video can be shaky, making it not really appealing to watch. Here, we can use optical flow to calculate the most dominant direction. Usually, it will be related to the background. This is because as we move the camera, all the scene moves in a similar way. And although many objects might be moving in different directions, at the end, the most dominant orientation will be related to the camera movement. So we can use that information to warp each video frame and compensate for the movement, resulting in a better video quality. Finally, a really active area in computer vision is related to pose estimation and body tracking. And it doesn't matter if you want to track the whole body or a single body part. There are many things that need to be improved. Currently, there are several approaches that use more advanced algorithms, such as convolutional neural networks, to model the body and track it with high accuracy under challenging conditions. But this will be part of an advanced course. Okay, in this video, we talk about some applications of optical flow and some challenges that we can encounter when we try to track objects on images. See you next week!